Students, people, welcome. Today, this is Mr. Swearingen coming at you again with some more algebra. Woohoo! This is 7.2. So in 7.1, we talked about exponents, we learned what a base was, and then we learned a couple properties. And so these first couple examples just look back on what we've already learned. Today, so we'll get to those examples in just a bit. The goal for today in 7.2, we're going to learn a new property called the product of powers property. And we'll use that to simplify our bases. With that, let's start on it. Let's remember, anytime our exponent is 0, we don't care what the base is, it doesn't matter. Our answer is always 1. Simple as that. Good as gravy. If it was 5 to the 0 power, it'd still be 1. If it was negative 10 to the 0 power, it'd still just be 1. Whatever it is. Example 2 with negative exponents. This is the one that people have the trickiest time with. What I'm going to say is, let's remember we can write this as a fraction over 1. We're allowed to do that because dividing by 1 doesn't change the numbers here. When we have a negative exponent, we take the base and the exponent and we move it to the opposite side of our fraction. So here we start with it in the numerator, so when we move it, we'll move it to the denominator. When we do that move, our exponent becomes positive. So now my answer will have a positive 3. Oh, did the format get a little wonky? No, just looks like this one. This should be 1 over 4 to the negative 2. 1 over 4 to the power of negative 2. But the same idea. When we have a negative exponent, we take the base and the exponent and we move it to the other side. Because we're starting in the denominator here, we're going to move it to the top row. We'll move it to the top, make the exponent positive. If it's helpful for you to see it as a fraction over 1, then you can write that in. But then we're going to simplify it. So, when we have a number base, we want to do that calculation. 4 squared, 4 times 4 is 16. And because we have this divided by 1, it's extra, we won't write that. So our answer here is 16. Now, these next 3 examples helps remind us what an exponent is. So here, if I wanted you to write 2 times 2 times 2 as an exponent, we would write it as 2 cubed. 2 because, well, that's the number we're multiplying, and 3 because there's 1, 2, 3 2's that we're multiplying. So here, our base is x. How many x's are we multiplying together? Well, there's 4 of them. For example 6, what's our base? Y. How many y's are there? Well, there's 2. Now we're getting into this product of powers property, where we see something like this. I'll go ahead and show you the answer that we're going to be looking for is 3 to the 7th. Maybe think about where that number is coming from. Do you see the trick? If we take this 3 to the 5th, if we add those two exponents of that base 3, we'll get 3 to the 7th. Here, I'll erase this. The reason this works is, well, let's take this apart. When we see 3 to the 5th, well, let's write that out. 3 times 3 times 3 times 3 times 3, right? We're okay with that? I'm taking my base of 3, and I will have 5 of them. Well, then let's look at this one. 3 times 3. There's 2 more 3's that we're multiplying in. Ooh, that's not what I wanted. There's some more 3's that we are adding in. Well, so how many 3's are we multiplying in total? 1, 2, 3, 4, 5, 6, 7. So 3 to the 7th. So we can see, we can break these problems apart to count, or the trick is just to add those exponents together. So here we can see this general sense. If we have 2 of the same base, we will add together the exponents. Let's get some practice. Here, let's pause. Go ahead and pause and work on these 3 examples, 8, 9, and 10. I'll give you a second. I'm going to go over them in 3, 2, and 1. Here we go. I see a base 2, I see a base 2. Good, they match. So all I need to do is base 2, and I'm adding the exponents together. I'm adding 5 plus 6. That's going to give me 2 to the 11th power. I would want you to multiply that out. Shoot, and I don't have, I'm going to run real quick, grab a calculator. And tell you what this simplifies to. Because it's a number, I want you to actually do this math. It's going to equal 2,048. Oh, excuse me. Example 9, nice and easy. We need to remember one thing here. When we don't see an exponent, so with this y, we don't see an exponent, let's remember we can always add in an exponent of 1. So to find our answer here, we're going to take y2 plus 1, which gives us y to the 3rd as our answer. Then, this introduces an interesting element, where now we have 2 different bases. I have A's and I have B's. Well, we can only group together, we can only do this products of powers property with same bases. So we can do A 4 plus 2, but that B is just going to have to, it'll just stay the same. There's nothing we can do to simplify that. So our final answer is going to be A to the 6th, B to the 5th. That's all we can do there. Now, these next 3 examples, these last 3 examples really, get a bit trickier. They add some extra elements, like negative exponents or 0 exponents. Here's what I'll say before I send you to work on these. Go ahead and group together all of the same bases, and then ask yourself, is there still a negative exponent? If there's still a negative exponent after you add, then flip it. I'll show you what I mean with example 11. If you want to try example 11 on your own, pause now. I'm going to start. So this will go base by base. Here I see the base 4. Well, I don't see any more base 4s, so I'll just rewrite it. Then let's go on to the base x. I see a base x here, I see a base x here. Let's remember once again, this x has that invisible 1 exponent. So when I add these together, when I group these together, I'm just taking those exponents exactly how I see them and adding them. So here I'm taking the -4 and the 1, adding them together. Let's do the same thing with y. I have -1, and then I have +4. So I'm adding those together. When I simplify these, I'll have 4. -4 plus 1 gives us -3. -1 plus 4 gives us +3. Good. Now that we've combined all the bases as far as we can, now let's look to see if we have a negative, which in fact we do. This x exponent is negative. So let's imagine that's over 1. Because it's negative, we need to take it and move it from the top to the bottom. So everything else will stay. The 4 will stay because it has an exponent of 1. The y will stay because it's a +3. The only thing we have to move is that x. Example 12, pause if you need time to work on it. I'll begin in 3, 2, 1. Okay, same thing. This 2 looks a bit funky. It should just be out in front. It's a base. Which, that's the only 2 I see, so I'll just write it. Now let's group together all the x's. Well, here I'd see x. Here's something that you can do. There's 2 different ways to do it. I'll show you the first. Because we have, and let me actually erase this just a bit. Because we see this x to the 0, that's just going to cancel out to be 1, so we can really cross it out and kind of forget it exists. Which means for our x's, we only have 1x. For our y's, we have this +2 and we have this -2. Ooh, you see what's going to happen? When we simplify, we'll get 2 times x times y to the 0. Of course, y to the 0 would also cancel. So our final answer would just be 2x. So you can do it that way, where when you see those 0 exponents, you just cross them out entirely. The other way to think about it is grouping it by base. So here we have our 2 x's. Well, here we have x to the power of 1, and then we would add that x to the 0 power. For y, we would have 2, plus a -2. Well, 1 plus 0 is still just 1. 2 plus a -2 is still 0. So it still ends up being the same answer. It's just a different way to look at it. Whichever one you like better, do that. Here, I'll split it so you see it's 2 different ways. This is the last example for this practice. Here we go. See how we see, the first thing I want to note is see how we have these multiplication signs? That's okay. We can kind of just group them together. Oh, like we did in the past ones. I forgot to mention them there. But when we see these multiplication signs, that's like saying the same thing as if they were all squished together already. So here, do you see how we have two number bases? We have a 3 and we have a 2. I'm going to go ahead and pull all of our numbers out, I guess, based off this video, all the numbers I'd pull out this way. So 3 times 2. Then, let's look at our x's. X negative 3 plus 1, because when we don't see it, it's 1, plus 2. And then the y's, I have y2 plus 2. Three times 2, well, we can just do that math. 3 times 2 is 6. Then we have x negative 3 plus 1 plus 2 will give us 0. 2 plus 2 for y gives us 4. Cancel out that 0 exponent. My answer is 6y to the 4th power. Okay, so these last two boxes, what operation are we doing in each example? What that's asking is, I'm going to erase these highlights real quick. When we just look at a problem, each of these individual bases, each piece, we are multiplying. Ooh, that is a funky, there we go. Multiplying. What do you do with the number bases? You simplify them. So like here I had 3 times 2. I went ahead and did that math. I simplified those. Or if I'm left with, let's see, what was the other example? Like example 8, if I have a number base with a power, I do that math. So that's that. That's the notes for today. You have these 8 practice problems to work on, and then turn in person. Thank you for watching. Hopefully this helps. Have a great day.